Let us continue our discussion on polynomials. In this specific lesson, we'll talk about what is the meaning of the term zero of a polynomial and how exactly you will visualize the zeros of a polynomial graphically, okay? To begin with, let me give you a very simple expression f of x, and this is equal to x minus 5. So x is the variable here, and I ask you this: for what value of x you will find the function of x equal to 0? So the answer is very simple. You will say that, well, if I simply substitute x equal 5, then the value of this function at x equal 5 will be 5 minus 5, and hence it will be 0, right? And mathematically, what it means is that if you define any function of x where x is a variable, and for a specific value of x, let that be the value k. If f of x is equal to 0, then we say that the x equal to k is a solution, or it is called a zero of a polynomial. Okay, so zero of a polynomial is the solution of that polynomial for which the function or the equation becomes equal to 0. It is as simple as that. And since the objective is also to analyze what is the graphical representation of the zeros of a polynomial, we will go take a look at some examples in which we are analyzing those polynomials graphically. Okay, let's go take a look at that. So here is our case one, that we are analyzing a graph that has a linear polynomial. Okay, so here is the equation of a line represented graphically. All right, now when we say the zero of a polynomial, it simply means that for what value of x the equation 2x minus 4 will be equal to 0. And graphically, what it means is that you're looking for that value of y, which is equal to f of x, at which the y will be 0. And the only case where y will be 0 will be when you have a line that intersects with the x-axis, right? That is the only place where y will be 0. And that is precisely this location for us, right? This is my zero of a polynomial. What it means to you in graphical sense is that you are looking for that specific value of x at which your polynomial will intersect with the x-axis, right? And at that specific point, you will have the function or the y value will be equal to 0. And one more observation we have is that in this case, the degree of our polynomial is 1. So we will have only one and at most one solution of this polynomial. Or you can say that the zeros of a polynomial at most will be equal to 1. There may be a case that you may not have any solution at all. But if you do, you are not going to have more than 1 zeros in the case of this linear equation because the degree of this polynomial is 1. Okay, so the number of zeros of a polynomial will always be less than or equal to the degree of a polynomial. And now we are analyzing a situation of a quadratic polynomial in which our expression is y is equal to negative x squared minus 2x plus 8. Okay, and the graphical representation of this equation is exactly as shown in this parabola, right? A blue line. And just like before, we are only looking at precisely at what locations on the xy coordinate plane we will find the solution or the zeros of this polynomial. And we observe that there are two specific points that this parabola will intersect with the x-axis. One of them is x equal to, y is equal to 0, and the second is x equal negative 4, y is equal to 0. So how many zeros you observe here? 1 and you have 2. So just to give you a perspective, we have the degree of this polynomial is 2 and we have two solutions of this polynomial at which f of x is equal to 0. In this case, we are saying this is y. So f of x equals 0 or y equals 0 means the same thing to us, right? So just like that, I have brought two more examples. So this was my graph 1, this is graph 2, this is graph 3, right? So in this case, this is also a parabola, right? And you see that it is intersecting with x-axis at only one location. So the degree of this polynomial is still 2, but you have only one solution or you have only 1 0 in this case, right? And then look at a case number 3 that you still have a parabola. That means It is still a quadratic equation. The degree is 2, but it doesn't intersect with the x-axis at all. There is a gap that you observe here, right? The number of solution in this case is 0, or you will say that the zeros are 0 in this case. Well, it is a little bit awkward to state that 0 is 0, but the 0 term here really means that the solution and the number of solutions in this case we are saying that are 0. Okay. So in the case 3 that we are analyzing a cubic polynomial. So you have two equations. You see the highest order in this equation is 3. So this has a polynomial of degree equal 3. Let's assign the names to these diagrams. So this is number 1 and this is number 2, right? In this case, I also see in the case of diagram number 2 that this has a degree of 3. But the question is how many zeros you will find in these polynomials? Well, so we will simply look at the points where these polynomials will intersect with the x-axis. So this is 1, this is 2, and this is 3. In diagram number 1, I'm finding that the number of zeros or the number of solution is equal to 3 because there are 3 places I see this curve intersecting with the x-axis, right? And in case of diagram number 2, we are finding that there is precisely one location at which this curve will intersect with the x-axis. So the number of zeros in this case will be equal to 1. And once again, this highlights a good finding that the max number of zeros we could find in any polynomial will be equal to the number of the degree of that polynomial. Okay. Now let us take a look at some more graphs and try to spot how many zeros or how many solutions of those specific polynomials you will find respectively. Okay. Let's go take a look at that. So if you were simply told that identify the zeros of polynomials or spot the zeros of polynomials as given in these graphs, in the case 1, you will say that, well, right here, because this curve intersects with x-axis at precisely this location. So this is 1, 0, right? In the case number 2, I don't see any place where it is going to intersect because this curve as shown here is not intersecting with x-axis at all, right? And in the case 3, you see that, well, this is intersecting with y-axis. So is here, and this is the only place where I see the curve intersecting with the x-axis. So this will be the 0 of this specific polynomial in number 3. Nutshell, what is it that we can take home from this discussion today? We can say that the 0 of a polynomial is a value of the variable that if you substitute that value in the expression in the polynomial, the net value of that expression will become equal to 0. Right? This is the meaning of 0 of a polynomial. And how do you visualize graphically is by the help of these examples that those polynomials, they have to intersect with the x-axis. With that, we will take a pause here, and in our next tutorial, we will study a little bit more about the polynomials and the zeros of polynomials.